Hello, ladies and gentlemen, and welcome back. Or if it's your first time, just welcome. We're going to be looking in this video at question number 21 on our 2018 Fermat paper. This is the first question in Part C, so it's going to be worth 8 marks, as are the remaining questions here. So we want to do well on these. These tend to be the harder questions on the contest, so let's take a look. A sequence has terms A1, A2, A3, and so on. The first term is x, and the third term is y, and they don't seem to be telling me these values. The terms of the sequence have the property that every term after the first is equal to one less than the sum of the terms immediately before and immediately after it. So they give us a nice little formula here. an plus 1 is equal to an plus 2, the term before and the term after, and then we subtract off of 1. The sum of the first 2018 terms in the sequence is. Alright, so there's nothing special about 2018 here. It's just the year of the contest, and it's a big number, so it's not like we can just write a few terms out and figure it out. So we're going to have to recognize patterns. Now, the thing I'm noticing when I look at these solutions here is they've got x's, y's, and a constant. Okay, and the x's and y's aren't that big. So I'm thinking that the terms might start cycling, and that, you know, you'll get an x here and a minus x a few terms later, and then they'll cancel out when we add things up. So I'm thinking it might be some sort of a cycle, where you'll get x's, maybe 2 x's, then no x's, then minus x, and then minus 2 x's, and then no x's, and then back to x's again, or something like that, where they'll start to add up and cancel out. Okay, and same thing for the y's. So when we're looking for a pattern, we want to keep these sorts of things in mind, these instincts that we have in mind. Now, there's sort of two patterns we could try and look at. We could look at a pattern of the terms, which is what I'm suggesting, based on the low numbers I'm seeing in the possible answers. Or we could write out a few terms and add them up, and then add another term, and then add that to the sum, and so on. And then sort of try and figure out a pattern for the sum of terms rather than necessarily a pattern for the terms themselves. Okay? Either way, a pattern should hopefully emerge, and we'll be able to get to the bottom of this. But what have we got going on? So, I want to keep track of the x's, y's, and the constants that are going to pop up. Now, we got x, we got something in the middle, and we've got y. So this is going to be x plus y minus 1. Sum of the two around it and then subtract 1. Now if I wanted the next term, it would have to be a, and then a plus x plus y minus 1 minus 1 is equal to y. This is kind of confusing. I can see this is only going to get more complicated, so rather than, say, use algebra to figure this out, how about we just rearrange the little formula that they bother to give us? So, keep an plus 2 on its side, and you bring the an over to the other side, and the minus 1 comes over and turns into a plus 1. Because other than this second term, I'm just going to know the previous two, and I want the next one. So why can't I just use this formula? So that'll mean this will be y minus x plus y minus 1 plus 1. And so we'll get y minus y, a minus x, and then minus 1 plus 1 is a 2. Okay. I can see even this is going to get kind of annoying. So let's keep an eye on our x's. Suppose the next two terms look like ax plus by plus some constant, and then the next term is dx plus ey plus another constant. What should the next one be? Because then the a's and the d's should tell me what x is, and then the b's and the e's should tell me the y's. So the next term is going to be previous term minus the term before that plus 1. So this ends up being equal to d minus ax plus e minus by plus f minus c plus 1. So, rather than write these guys out, I think I'm going to make a little sort of running table. So we'll have term 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to have what happens with the x's, the y's, and the constants. So we start off with 1x. Eventually we'll get 1y with no constants. And then in between we had a 1, a 1, and a minus 1. Okay, so this gave us y, x plus y minus 1, and just y. Now what happens for the x's? To figure out the new x term, you take the previous ones and subtract the 2 times previous from the immediate previous. So this will be 0 minus 1 or negative 1. And we did get a negative x. And we'll get 1 minus 1, 0 y's. And we had no y's. And 0 minus negative 1, minus negative 1 plus 1. And that's equal to 2. And we did get 2 minus x. But I think this will be a faster way to generate, because minus 1 minus 0 is just minus 1, and then minus 1 minus 1 is going to be a 0, and then 0 minus minus 1 is, hey, we're back to 1, and then 1 minus 0 should be 1, and then 1 minus 1 is 0, so it is kind of cyclic. And I suspect the y's, following essentially the same pattern, will work out the same. So 0 minus 1 is minus 1, and then we'll get minus 1 minus 0 is minus 1, and then 0, and then 1, and then 1, and so on. Okay. So it looks like the sum of, at least when it comes to the x's and y's, every 6 things will cancel out. 1 and a minus 1, 1 and a minus 1, and of course the zeros cancel out. 1 and a minus 1, 1 and a minus 1, and the zeros cancel out. So every 6 terms, this is why the x's and y's are so low in the possible answers, because every 6 goes away. Every 6 terms, the x's and y parts cancel out. So I'm going to grab my calculator and figure out 2018 divided by 6. What's the remainder there? So it looks like it's a remainder of 2. So, how can we use this to our advantage? What does that mean? 2016 is a multiple of 6? Yeah, it is. So it looks like, let's just go back here. So without worrying about the constants right now, because maybe we can do this without considering the constants. So you'll notice that the 9 column is the same as the 3 column, at least when it comes to the x's and y's. So the 2016 column is going to look like the multiple. It differs by 6, so the 8 column is the same as the 2 column, for example. And so any multiple of 6 will look like the 6 column, so it'll look like 0 and minus 1. And then 2017 will look like 1 and 0. And then 2018 will look like just regular 1, right? Yeah, it'll look like 1, 1. Okay? But every group of 6, they cancel out, so we're just left with an x and another x and a y. So we're looking for an answer that's got 2x plus y in the whole sum. Now, crazy stuff has been going on with the constants. Maybe we can avoid that. How many answers have 2x plus y in them? Just one of them. E. So we don't have to worry. If we are confident in the pattern, we're done. The answer is just going to be E, and I don't have to worry about what the heck's going on with the constants. Because the constants, it's not as nice a pattern here. I mean, yes, it is a pattern, but 0 and then minus 1 and then 0 and then 2. And then you'll have 2 minus 0 plus 1, because it's always, so here's your C, here's your F. It's always F minus C plus 1. So 2 minus 0 plus 1, we should get a 3 here. Then 3 minus 2 plus 1 is a 2. And then 2 minus 3 is minus 1 plus 1 is a 0. So it looks like 7 is just going to be X all over again. And then 0 minus 2 is negative 2 plus 1 is a 1 here. So you'll notice it's different than what happened with the 2 over here. Okay? And there's this sort of, it's a harder thing to, I guess, get a handle on, which, you know, is kind of annoying. But if we just take a look at the x's and y's, the thing that really caught my eye is how low the values, the coefficients next to the x's and y's were. And that just sort of simplifies the whole thing. I don't need to understand the constants at all, because we've got our answer. We understand the pattern. We understand why it worked. Every 6, the x's and y's are going to repeat. So you really just need to worry about 2017 and 2018. How many x's and y's are they bringing to the party? Okay? So up next will be question number 22. Hopefully it'll be just as interesting. If you haven't given it a look, I would seriously recommend taking a look at that question before watching the video. Practice makes perfect. Spectating is, you know, just for fun or just to check your answers. But really, you should be trying these questions on your own. Okay? So I'll see you for question 22 next time.